Hello there, and welcome to the March edition of the Manitowoc Ice Monthly Spotlight. My name is Jason MacDonald, Technical Service Trainer here at Manitowoc Ice, and today we're going to talk about head pressure and its operational impact on ice machines. We're mostly going to discuss the Indigo Next series, Neo and Cool Air, but a lot of these principles can be applied elsewhere. So we'll get the dual screen going and start our presentation. As we do with each seminar, each monthly spotlight, or its predecessor, the webcast, there will be a quiz at the end of this. A few keys that we're going to need. We're going to need information from you, as well as answers to the questions, but really an email address is going to be key. And then at the end of that, you need to click submit. Once we get that information, we will send out a PDF version of the presentation, a certificate of completion, and then enter you for our monthly drawing. All right, so head pressure control. We're going to talk about all condensing options. So self-contained, air-cooled and water-cooled, traditional remote, and the remote condensing option, or the CVD systems. All right, we'll start with the self-contained. So we do that one of two ways. We either do that with a water-cooled condenser, just exactly as it sounds, cooling that condenser down with water to control head pressure, or with an air-cooled condenser, which depending on the style, whether it's self-contained, which we're talking about now, that'll be a fan motor and a fan cycle control switch controlling that, or other systems have the fan running all the time, but we'll get to those in a bit. So how do we control that head pressure? Well, on the water-cooled system, we use a water regulating valve to let water come through and maintain our head pressure. And on the self-contained air-cooled, we're using a fan motor to get that heat out of that condenser, and that fan motor will be tied in series with a fan cycle control switch. So, water regulating valve operation. It's internally regulated. There's a spring in there to let the right amount of water through, and that's going to control your head pressure. Utilize your technician's handbook if you're questioning anything going on with your head pressure. It's going to give you a range with this, and with a water regulating valve, you can set it. So the key there is you're going to want to go right to the middle of that range. If you have a 310 PSI to 320 PSI range, you must be working on one of our 410 systems, but go ahead and try to get that head pressure right to 315. Again, the correct settings can be found at the back with the pressure charts of the applicable tech handbook that you're working on. All right, so how do we adjust this water reg valve? To do it properly, we need to be EPA certified and have a gauge on the high side so we can verify that head pressure is correct. If your head pressure is too high and we're not letting enough water through that system, or hey, the water temperature changed and it's a lot higher now, so we need more water flow to properly regulate, you're going to turn that valve clockwise. Turn it clockwise will decrease the pressure, and if we turn it counterclockwise, we will increase the head pressure. Big thing, if you don't remember this at the end of the day, one of the things that we teach in the factory school is have that gauge on there, turn that valve just slightly. If you were trying to go up and you went down, well, sorry to tell you, you're going the wrong way. Let's turn that valve the other way and get our head pressure set. Key with this is remembering that this is what we utilize, whether it's a hand valve or a special wrench that needs to be turned to adjust that head pressure. During harvest, one thing that we want to mention though, water should stop coming through that condenser 100% of the way. So at this point, it's refrigeration diagnostics. If you've got water coming through your water-cooled condenser during the harvest sequence, one of the first things tech support is going to ask you is what your head pressure is doing. Keep in mind, if your head pressure is above the set point of the valve, water should be coming through. At that point, we'd probably be asking you things about power to the hot gas valve. If we're on an Indigo or Indigo Next, getting yourself into real-time data to verify you're really in harvest. Other machines, verifying based on the harvest light, so that way we can troubleshoot properly. But if you are below the set point of that valve and water continues to flow through the water-cooled condenser, you've got a water regulating valve that will not regulate. You're going to need to get a new valve that will. All right, but what about our air-cooled machines? So the units that we're talking about in the United States anyway are made with either R410A or R404A. So for the Cool Air modular units, they've been on 410 since they were launched in 2015. So the specs on this pressure switch, even though we only call out Indigo Next on this chart, would also be applicable. So on 410 systems, the pressure switch opens at 275 psi. That's where it should cut out, and it will close and call for the fan at 335 psi. Now we do give you a plus or minus 5 buffer in there. You got to be able to compensate for reaction of the switch. Maybe our gauges have been dropped a few too many times, aren't calibrated, so don't want to jump the gun when we see 238 If it was a 238 switch, well, this one's 275, so 278, not going to freak out about that. Then we also have our 404 systems. We have two 404A pressure switches, one that cuts in at 250 and cuts out at 200 psi, and another that cuts in at 275 and out at 225. So if you're wondering about that switch, but you have not gauged up yet, this is what you want to look for. If the fan's not running, is the pressure switch closed? Well, if we're above that cut-in, and to know if we are above the cut-in, you would need a gauge, but let's say that we're just really not wanting to gauge that up to that system. Everyone here at Manitowoc tells you, do not put gauges on until you're sure you need them. Well, if that system continues to get hot or continues to shut down, and you're reading line voltage, and the fan never comes on, well, at that point, we're going to need to see what pressure is doing. So we put a gauge on that system, and you're above the cut-in. If you're reading line voltage, you got a situation where the switch is not closing. But if you're reading 0 volts, that switch is closed and the fan motor should be running. So keep in mind, if that fan switch, you're reading 0 across it, you have power to that fan motor, and there's no restriction, no loose fan blade, it's not caught on something, anything of the like to prevent that fan motor from turning, then you would have a fan motor issue. You would need to replace that fan motor because you verified that the fan switch is doing its job. Now the fan's not listening. So we're utilizing these things to control head pressure for operation and to protect the system. Well, we also have a high pressure cutout switch in these systems. So for the 404 systems, that switch will cut out or open at 450 plus or minus 7 psi, and it will cut in and close at 300 plus or minus 10 psi. On the 410 system, 410 runs a lot higher. It cuts out at 600 plus or minus 10 psi and cuts in and closes at 450. Just like we were doing before, if you're above the cutout, so above 600 on a 410 or above 450 on a 404 system, you should read line voltage and that switch should be open. If you're below the cutout, however, you should read 0, especially once you got to that cut in because it'll automatically reset. So keep in mind, it's got to get down to that point where it'll cut back in. But as long as you're below the cutout, that switch should be closed. And that switch should be giving you a 0 volts reading when you have your meter set to volts AC. Keep in mind on this, if you were looking for the Indigo, the Neo, the Cool Air, the S series, the Q, the J, any machine that we've made, you can utilize our website. Go to manitowocice.com, click on the Downloads tab, and then click on Document Finder. You'll have a drop-down menu for service manual. Do want to stress, however, if you put the full model, let's say it was an S model, an SY0504A-161, if you put that, it's not going to give you anything. If you put S space model, you'll tend to find it. One of the recommendations I usually give is just put service manual in the document type and then click go. Don't put anything in that keyword search. It'll give you every technician's handbook we've printed, and you can download them for free. All right, but what about our remote options? So on the left side of the screen there, we have a traditional remote condenser. So we've got our condenser, our fan motor, and in that system, there'll be a head pressure control valve or headmaster. And then we have our CVD systems, the remote condensing units, the quiet cubers, as we like to call them. That will have your compressor, your headmaster, your condenser, your fan, your low pressure, high pressure switch, and a fan cycle control. We'll get into why that has both in a little bit. Keep in mind for traditional remotes, again, that picture on the left, current production does not have a fan cycle switch. There is an F1 and F2 line in the back of the junction box of the electrical connection box in the ice machine head downstairs that you're supposed to run wires up with the lines and wire the fan motor. So on that left unit, that fan motor should be running whenever the contactor is pulled in. On our machines, the contactor should be pulled in 5 seconds before pre-chill starts, through pre-chill, through freeze, and through harvest. So all of those steps, if you have a traditional remote, the fan motor should be running. On the right-hand unit, we have a fan cycle switch because we're trying to get that discharge heat from the outside unit downstairs, utilizing both a headmaster and to shut off the fan. We don't want to reject heat in harvest. We want to get the heat downstairs, and we're utilizing the headmaster for that. The left-hand unit, we're utilizing the headmaster to keep liquid line temperature and head pressure right, and we'll get into that here on the next slides. So Remote condenser, again, we're utilizing a fan that should be running at any time that the compressor downstairs is, and we're utilizing a head pressure control valve or a headmaster. It's set to bypass the condenser to regulate our head pressure and ensure we have enough heat so that way we can harvest. Liquid line stays warm, allows us to build heat on the discharge line. We need these things to do their job, and we'll get into how to troubleshoot that here very shortly. So, on the left, you will see a valve that is in non-bypass. So we're sending gas to the condenser to flash back to a liquid back downstairs to the receiver. But on the right-hand side, what we're going to do is there's nitrogen up there. It's going to redirect the flow of that discharge gas instead of going through the condenser to go back through the liquid line to the receiver to maintain our head pressure and to continue to ensure that the receiver is warm enough. So what's going to happen with that one is as you get to the point where that headmaster is supposed to bypass, this is a 410 system, it'd be right at 300 PSI in current production. On our 404 systems, we had 225, we had a 240, might have even been a 260 PSI. Utilize the Easy Parts web. You can find that at manitowocice.com. Click on service and click on electronic part document catalog, and then look for the proper unit you're working on and verify what that headmaster is supposed to bypass at. But the whole point is we're going to redirect flow downstairs, and as we stop rejecting heat, head pressure will climb, and we will then redirect that discharge gas through the condenser. So, just told you about how it's trying to regulate head pressure. So head pressure and liquid line temperature will tell us quite a bit about this valve. So if your discharge pressure is normal and the liquid line temperature is warm, hey, we're troubleshooting the wrong component. Everything's doing its job. What if that discharge pressure is high? I'm supposed to be no lower than 300, no higher than 350 based on my conditions outside, but I'm sitting at 400, 500 PSI if we're getting into a 410 system and climbing towards that high pressure switch at that point. Well, high head pressure, hot liquid line, that's a valve that's stuck in bypass. We're not letting that discharge gas get to the condenser to flash back to a liquid and reject heat. You're going to need to recover the refrigerant out of the system, cut out the headmaster on the roof, cut out the dryer downstairs, braze in new, purge with nitrogen while you're doing so, and then recharge to the nameplate weight. Remember, the nameplate charged on the downstairs unit, and that amount on there is good for line sets up to 50 feet. For line sets between 51 and 100 feet, you need to reference the installation, operation, and maintenance manual or your technician's handbook for any additional charge needed. All right, but what about if our discharge pressure's low? Hey, I'm not supposed to get below 225, but I'm down at like 190, 195. Well, what's your liquid line doing? If you grab onto that liquid line and it feels cool, hey, what if you think you're not sure? You're not sure if it's cool or if it's warm or not. Go ahead and pop a hand up on your head, your other hand on that liquid line. Which one's warmer? If it's your head, let's be sure you don't have 105-degree temperature going on, but assuming that you're not ill and running a fever, if your forehead is noticeably warmer than that liquid line and your head pressure is low, that's going to be a situation of your headmaster failing to bypass. It's not regulating. It's not redirecting that flow. You need to do the same thing you did with one stuck in bypass. Recover the charge, cut out the headmaster, cut out the dryer, braze in new while purging with nitrogen, recharge to the nameplate weight. Cannot stress that enough. Ice machines are charged by weight, never by pressure. But what if the discharge pressure is low? Again, hey, we're at that 195 mark, but the liquid line's hot. Well, that's a headmaster that's doing its job. It's trying to regulate the head pressure, but you don't have enough refrigerant in that system to get that head pressure up there. Hey, you're low on charge for some reason. Let's verify that people weren't just hooking up 6-foot hoses 17 different times, but more likely than not, you're going to find there's a leak in the system. Repair the leak, replace the dryer, charge up to the nameplate weight. And that's how you troubleshoot a head pressure control valve. These really come into effect at this time of year and in the northern regions in the fall, Halloween through now, below 70 degrees. All right, but the CVD systems, a little bit different there. We have a fan motor, but we also have a pressure switch to call for that fan motor. So the same way you would diagnose a pressure switch on the self-contained air-cooled, the same principle is going to be here. And we have a head pressure control valve to maintain head pressure. So we want to bypass that condenser and keep the receiver downstairs at an acceptable temperature. So that way when we do get into harvest and that headmaster needs to slam into full bypass and it all of that heat that we can back downstairs as fast as possible, that we are at a temperature that'll allow us to boil off that refrigerant and send vapor through the harvest valves. Keep in mind, on CVD systems, we are using a cool vapor defrost. We are not doing traditional hot gas. It's still a valve, letting pressure through, letting gas through to bypass the TXV and melt, but the headmaster on this unit serves two purposes, and we don't want that fan running during harvest, so we have a fan cycle switch. All right, but high head pressure, what will you see on each machine? We're going to talk about that now. So we're on an Indigo next, the current line that you'll see out there, and what we're looking for is, hey, we're seeing the machine, customer called, we don't know the problem yet, just turned it on, and that high pressure switch opens. Maybe we don't see it because we stayed on that home screen. Real-time data is your friend. We'll show you how to get there. But if this is what you were looking at and that high pressure switch opened, this is what you'll have now. The unit will go to machine off. All right, machine is off. Let's go see what we're going to see. Because if this was an Indigo, old Indigo with the touchpad, if you went to a high pressure event, the home screen would have went from making ice to HPCO active delay and giving you an hour countdown, 60-minute countdown. This machine just goes to the off state. So what are we going to do to find out what's happened? We're going to hit that menu icon, go to service, and we want to see what's happening right now. So we need data. So we're going to go to data. Well, we want to know what's happening now, so we're going to go to real-time data. And we picked time and temp this time. Well, we're in the time and temperature menu, and you're going to see that it says HPCO delay active whenever the high pressure switch on an Indigo Next opens. Now, keep in mind, the high pressure switch needs to be inside the unit. On the CVD systems, those are outside, so you're not going to see that happen. You would just have the condensing unit outside shutting off, but the head unit would not be getting that information. No interconnecting comm wire on a CVD Indigo Next. So this would go for 10 minutes, and it would kick itself back on. But if you want to find out that you had a high pressure event, you need to get into real-time data. But what about Cool Air and Neo? They don't have displays. They don't have anything from the high pressure switch plugged into the board to tell that board, hey, this happened. Well, Cool Air and Neo, they use the same board. So we're using the wiring diagram from the Cool Air. Wire numbers and maybe the component number on there on the chart would be a little bit different on the Neo from the Cool Air, but it's the same board, so it's the same principle. What you'll see there, component 31, that is your high pressure control. It's coming from the board to the contactor, well, coming from the board through the pressure switch to the contactor. Well, if that high pressure switch trips open, what's going to happen is we're going to send voltage up to the high pressure switch, and it's not going to go through and get to the contactor. So what does that mean to you and me? Well, to me, that means that the rest of the machine's going to run. If this was an old piece of equipment, S series or earlier, the high pressure switch was wired in series with L1 going to the board. So on this style machine back then, that was wire 55, and on the Cool Air, it's also wire 55. You'd lose wire 55 and all lights would turn off, nothing would be running until that switch automatically reset itself. Then it would boot back up and start back up. Well, for Cool Air and for Neo, all you're going to lose is the contactor. So if you're running and you had the compressor and it just stops, first thing you're going to want to check is the contactor still pulled in? If it is, we're troubleshooting the wrong thing. But if it's not, check for voltage across that coil. No voltage, high pressure switch must be open. Go check across it. Again, if it's open, you'll read line voltage. If it's closed, you'll read 0. But this can lead to a safety 1 if it's happening repeatedly. Keep in mind, these machines have a safety limit 3 and no water safety. So if you're running constantly without refrigeration and having to restart it because of a high pressure event, you're going to lead to an issue with your freeze. So keep that one in mind as you're troubleshooting in the future. And again, like we just said, that high pressure switch is not wired directly to the board. It's wired in series with the L1 wire coming from the board to the contactor coil. All right, but head pressure too high or too low? We're still talking about head pressure, but mostly here we're going to talk about if it's too low. Big thing with this one, this is the symptom 3 flow chart. This is how you troubleshoot your harvest in a situation where you make good ice in a normal amount of time. Keep in mind, it's saying at the top there, the freeze cycle is normal. It means it makes a normal sheet of ice in a normal amount of time. Well, first question we're going to ask you, is discharge line temperature normal? On current production, on almost every piece of equipment I've ever troubleshot for this company, normal is going to be greater than 150 degrees. You need to be at 150 degrees or more at the end of your freeze cycle. If not, you're going to have issues with having enough heat to harvest. Low head pressure while making a full sheet of ice in a normal amount of time will lead to a lack of heat, and it will lead to harvest problems. If you were running so cold that there was no heat, no matter that harvest valve opening or not, keep in mind on there, we can utilize head pressure in the harvest sequence as well. So hey, let's say that that wasn't our issue before we go forward. Harvest valve's on, head pressure is high in harvest, and the suction's low. Well, that's a valve that's not regulating. But if we didn't have the heat in the first place, we need 150 and we have 70. That valve can open all it wants. We're not going to melt much ice, but we might run into what we call symptom 4. Hey, we don't have that heat, but we are melting, and it's just not melting fast enough, and then we end up timing out on our harvest, or we melt enough that it slides forward, but it's melted so much it's not heavy enough to fall. All of these things can lead to harvest issues. And one of the first questions we ask is, was the freeze cycle normal? And normal includes full sheet of ice within the prescribed amount of time, and if the compressor is indoors, that the discharge line temperature has gotten above 150 degrees. So, what about pressure conclusions? If you're running high head pressure and not too high a suction pressure, you're going to have slower freeze times. Let's say that the machine is boxed in as an air-cooled unit. The one right behind me is an air-cooled ice machine. If it didn't have clearances, it could be 70 degrees in that room, but it could also be sucking in 110, 120 degree air because it's pulling in the same heat it's rejecting. So that's going to make it go slower. You're going to have a hotter than normal compressor. Discharge line's going to get hot. Top of that compressor could get hot. Depending on how bad things are going, whether it's a pressure regulating device like a fan cycle switch or water reg valve, you could have a high pressure cutout. That point, you're going to want to go diagnose what's controlling head pressure. So water reg valve, condenser not being plugged on the water cooled, fan motor not running, pressure switch not closing on the air cooleds, fan motor not running on the traditional remotes, fan motor and pressure switch on the CVD systems. But what about low head pressure? Well, if your suction's also low, you're going to have slow freeze times. If you have lower than normal head pressure and lower than normal suction, especially if you've gone through a full freeze and harvest, if it's low during both of them, that system's low on charge. You've got a leak somewhere. We got to find it, repair it, charge the system back up. And you'll have a hotter than normal compressor, especially if suction's low. If they're both low, we'll build up too much heat. And let's say that suction's right, but head pressure's low because we got a fan switch that's supposed to kick on a 410 system at 335, but let's say it's kicking on at 250. Well, we're going to run a lot cooler. We'll make ice without a problem. Not going to build up that heat though. You're going to have harvest issues. Same thing could be true with a water reg valve letting too much water through. Same thing could be true with headmasters on the traditional remote and CVD systems not bypassing. So you want to be able to see what you're dealing with when. It can lead to freeze issues. It can definitely lead to harvest issues. But the thing that we're stressing it is if the freeze is normal, you're looking at what's going on with head pressure and why you're not building up heat. So we do want to talk about a couple of our upcoming spotlights. We have the next 3 months called out. Next month in April, we're going to talk about the USC 50 or Crystal Craft Premier service limits. There's 5 of them. So we'll go over those 5 service limits and what you should be looking for to troubleshoot them. In May, we're going to go over the Indigo. That's the one with the display and the touchpad, and the Indigo Next display with the touch screen. What the LEDs on the board mean. Green LEDs for things plugging in, input devices, red LEDs for output devices. And then in June, we're going to talk about Neo and Cool Air's lights. Remember, mentioned earlier in the presentation that they share a board. So we'll go over that with both of them in the coming months. But the technical training team here at Manitowoc Ice, we've got a lot of ideas here that we're working on. But you know what? Maybe those ideas are not things you want to see. That's what this QR code is for. We'd like the chance to get your ideas and try to make them on up for you. We've got a lot of them, but there's only so much we can think of. So help us out. Give us an idea of what you'd like to see, whether it's for a monthly spotlight in our 30-minute videos or one of our Ice Tech FAQs, the shorter 5-minute or less videos about, hey, here's my problem and here's what I find. Give us that info and we'd love to give you a shout out in the future. So at the end of the spotlight, you're going to see a QR code. Also want to stress that this is just one of our ways of training. You could also go into manitowocice.com, click on service, training, and the level 3 factory school tab and see what our schedule is going to do. Have a link to registration form, and it'll tell you what it costs, what we cover, what we don't cover with the cost of tuition and those things. So take a look there. But remember, when you're done with this quiz, please answer that email, answer all the questions. But when you're done, don't forget to click submit, because if you don't, we'll never have gotten it and we won't know. And we're still doing our swag bag. So if you submit within the first month after we've aired the webcast, well, now it's a spotlight. Back then it was a webcast. But within a month of the original day of posting to YouTube for the spotlight, we will draw one name for every 25 quiz submissions we get. So if we get 50, we'll draw 2. If we get 100, we'll draw 4, and so on. And here is that spotlight link. We will try to get that link dropped into the comments section on YouTube. But here's the QR code now, so that way you can see it. And we'll just pull that up onto the screen for you now. Last thing I want to discuss is thanking you guys for all coming and watching our videos. Thank you for all the kind comments we get over the months. Good luck on your quiz. Again, my name is Jason McDonald, Technical Service Trainer for Manitowoc Ice. Have a nice day.